So this is the Viking Mars Missions Education and Preservation Project second unboxing. And today I have with me
Tom Dahl,
who is a expert 3D modeler of the Viking lander that he's been doing an incredible job. And we are going to open this box because it says on it GCMS, SIP, and EAA, blue, and, well, you can read it. And yeah, so we're hoping to find some diagrams that will be useful for Tom's work. So let's see what happens. Let's see what we find. The great mystery unfolds. So the gas chromatograph mass spectrometer is what the GCMS stands for. And that was the principal investigator for the GCMS was Dr. Klaus Beeman at MIT. Dr. Beeman was worked on the instrument prior to, he worked on a lot of studies at MIT, came as a graduate student, postdoc from Austria to do his work at MIT, and then later became a professor there. And during his years there, both as a researcher and a professor, he was one of the foremost individuals that studied this particular line of work at MIT and also in the industry. So he was a pretty remarkable gentleman. And we had the honor of interviewing him a number of years ago. And we are really, really grateful for all of the information that he shared with us about his instrument, and also just about the mission in general and what it was like to work on the mission, and also his childhood. So this particular box was actually sent by one of the engineers who worked with Dr. Beeman on the engineering side. And his name is Dahl Rushnick. And we are very grateful to Dahl and his family for preserving and donating all of these archives to us. And excited to see what's in this box. So, drum roll. We're almost there. And we're grateful to have Tom doing this because he's very meticulous, like we are. And one of the things that we never know is exactly how things are packed before they come to us. So we have to be very, very careful in opening them, because in some cases we've had boxes that had no packing protection arrive. And then that's something that, yeah, archives come to us in all kinds of conditions. We'll just say that. One of the very, really exciting pieces that we have, which is one of a kind, is the azimuth charts. And those were stored in one of the Vikings' attics for many years. And unfortunately, those were partly consumed by mice in his attic. So, okay, I am going to do no more filler talk, and we are going to see what's inside this box. So this is the first time that these files will have been seen in many, many years. So let's see what we've got here. Well, there's the two blue notebooks that he referenced on the front. Let's see what we have inside them. FTOS, outdated. Okay, that sounds like, well, I'm not going to make any assumptions, but the computing systems that were used for these, it sounds a little bit like. Oh, interesting. Okay. So these are the schedules for what was done on different days. Actually, this is very interesting. This is going to give us a lot of information. So, yeah. So when every instrument was operated, there were plans made in advance as to what they wanted to do on specific days. So there was a primary mission of 90 days, and they pre-planned all of the things that they wanted to do. Now, what we do know is that, number one, we didn't land on the date that was expected. So that 90-day mission plan was outdated as soon as we discovered we couldn't land there. So that's one possibility as to it being outdated. But there's other possibilities as well. Once we collected certain types of data, we also discovered that we didn't need other sets. Now that says sample sites. Oh, interesting. Okay. This could be very interesting. So there were a number of different sites that were reviewed for sampling, possible sampling. And they were obviously not all used, but they were analyzed by teams of scientists. So this, you see here the survey of the sample site, and then an analysis of potential, let's see, I'm reading as I go. So yeah, surveying it, deciding whether or not they're going to take the actual images, whether it's black and white or color. Yep, and then there's little milestones that note different things that happened in the mission that they want to, that are sort of drivers for some of the images that they take, actually, and reasons why they may or may not take something from a specific site. So this is incredibly detailed. This is telling us basically all of the reasoning for why they took different samples in different places. This is actually a really exciting document here. So, and there you see, actually, this is interesting here. You see an uplink command conference there. So on the bottom line there on Sol 5, for every time they took an image, it would be then analyzed by the science team, and then they would decide what to do next. And every time they decided to change a sequence, they had to have an uplink command conference and test each one of those sequences on the test lander that was at JPL at the time. And then they would determine whether or not that would happen. And as Tom is pointing out there, it gives us a potential date, what they want to do, and the actual time frames in which everything is going to happen. It doesn't mean everything did happen in those time frames, but that was the plan. And you can see just how detailed these plans are. In fact, we've got individuals that were working on them. And oh, here's the azimuth charts. Okay. So now these are really important because the azimuth charts are actually a representation. Oh, is there another one in there? Okay. Okay, great. So the azimuth charts, and that's what this is, are a representation of all of the camera angles and the field of view, if you will, for places where an image could be taken or a sample could be taken. And you see that on the diagrams that on the coordinates, X and Y coordinates, there are actual squares drawn into them. They're faded somewhat. But when they wanted to take an image, the team would actually use a red pen to make a square, to select one or more of those squares for a square or rectangle image, and that would represent what that camera was going to be taking a picture of. So you've got two different field of views. You've got two cameras on each lander. Mm-hmm. So you've got a different azimuth chart and field of view, one for each camera. Mm-hmm. So this is actually telling us exactly what, and then here we go. So this is another type of diagram that was used to determine from a top-down view where the samples were going to be taken. And what this is sort of a radial diagram that extends out from the footprint of the lander itself to the length of the surface sampler arm and the furthest reaches of the imaging from the cameras. But this is done again from a top-down view. So that's pretty cool. And just to have a notebook that's got all of the decisions before they were actually made is pretty exciting. Okay, so we see something with instrument on it, and that got Tom's attention because we're looking for images of the instrument so that he can model these in 3D, which is really, really pretty exciting. Okay, so we've got a number of different sections here. We've got Viking 1 landed, which is going to say, I don't know what's going to be in there. Instrument status report. Oh, okay. The operation, yep, and then the data evaluated, frames generated. So these are the day-to-day reports on each of the instruments as they were being utilized throughout the mission. And this is after the fact. So this is Sol 1. Okay, that's really interesting. This is actually Sol 1. Yeah. And the plot start time, it says there, is GCSC time 6434, which honestly I'm not entirely sure how to interpret, so I'm not going to pretend I know. And this is a graph of the GCMS ion pump current. So this was they were testing it, basically. So this is a result of the test to make sure that it's operating the way it was expected. And they would have been doing this for each one of the systems before they utilized it in order to make sure that the data that they were collecting was actually going to be accurate. So if they found errata in any of the data during the data tests, then they would have actually realized at that point that the data that they would get out from the science instrumentation standpoint would have been imperfect. But if the tests all performed accurately and indicated that the instruments were working well, then we could move forward and do some science. And as we know, Viking was profoundly successful, despite many, many people who were skeptical, including Vikings themselves. I mean, it was a very ambitious program. So here we have a record of, this is actually telling us what the timestamps mean and what they equate to. So this is all Sol 0 to Sol 1. And every time is recorded as a different kind of a number. So it's kind of interesting how that gets represented. Yeah. And some of this we actually know what it means because we have the computing software plans. There we go. You can see that. We have the software plans that describe how the computers are supposed to operate. But in some cases, we are still looking for the documentation that talks about what all of these fields were. So we have collected a lot of this, but we still have some gaps. And this is really exciting. The GCMS is the instrument that there's the least documentation on, and it looks like we have most of it, most of it that's known to exist today, at any rate. So these are charts. Oh, again, okay, these are base plate temperatures. And then they were filled in with, you've got the red and the blue dots, and down here we have SIT and SST. I don't know what those are, so we'll find that out at another time, and we'll try and answer any questions that folks may have. Now these are all Sol 5. So it looks like a lot of this is going to be happening for, basically every day.
Different events.
Yep, these are different. Yep, as Tom has pointed out, those are little after-the-fact markings of events that happened at those specific times on those particular sols. This is really exciting. This is great. So what you see for all you students that are looking at this is that you have a plan, and then you test when you get to wherever your craft is. You test to make sure that your plan is still will have integrity in situ, because it's very different here on Earth than it is wherever you're sending your spacecraft to. And then once you have that plan and you realize and you do all your tests on your instruments and you can move forward, then you begin doing your science. And there are many, many instances in which things don't go as expected. So for example, Viking 2 foot pad was actually, one of the foot pads was on a rock, and so it was tilted, and so some of the field of views changed from the azimuth charts. So these are really good examples of, what might be different. We won't say wrong, because you're planning to go to a planet that's millions and millions of miles away. So getting there is very remarkable. Oh, now this is the instrument status. This is a great page. So you can see in the left hand, you've actually got all of the functional units within the system itself and the actions that they can take. So you can read those there. I'm going to zoom in on it a little bit and hesitate so folks can read that. And then to the right, if I scan slowly, you can see what the result sets were for each of these instrument parts for this particular time frame. I'm going to zoom out again. That's really interesting. And we've got more graphs. Let's see if we can find. Okay, so we've got the same chart for a different day. That was for August 6th, 1976, most likely. Does it say 1976? Doesn't say 1976, but my guess is this is probably for the primary mission, which would have meant that it was 1976. And, oh, actually, now that's interesting. This must be European dates because the first one said August 6th, so it must have meant June 8th.
These could be during cruise.
Yeah, well, if it was June 8th, then it was actually they were testing these instruments when they were in flight to Mars and had not yet reached Mars. So, yep, this is something we just discovered by looking at this, and this is a good clue. We know that this is actually June 14th, so these would have been flying. They were testing the units while they were flying to Mars and had not yet gotten there. So this is what historians do. We are sort of like investigators, so we have to look for clues, and that clue gave us the indication that what we thought might be accurate in a date was actually not. Here we go. Here, we can just, if you want to let go of the top pages, then I think we'll just have to open it up. Yeah. That's okay. I've had to open these up many times, so that's okay. You got almost all of them there. This is the beauty of mechanics. Yeah. This is something that happens with us historians all the time as we're going through documents, so nothing unusual here. These were not the droids you're looking for. Anyway, that was a pretty exciting notebook. Probably not going to have any of the diagrams we're looking for, but thank you, Tom, for being patient with that as we took a peek. Now, what's that one? That one looks like it might have something interesting in it. Yeah. I mean, it looks like it might have potentially something more diagrammatic anyway, since that's what we're looking for. VL2 Bonneville sample. Oh, no. So this is...
That's the code name of a sample site. Yep, that's exactly right. That's so... Oh, boy. This is a very old... Okay. Schedules, notes. Okay, these are going to have images in them, I can tell already, which is what I saw the edges of. So we're going to see plans. My guess is we're going to see plans. Then we're going to see what might have been executed against the plans and some of the results. So yeah, so these are things that were planned. Second acquisition. This is bio is the biology instrument. X-ray fluorescent is the XRFS instrument. Dr. Ben Clark, biology. There were 3 investigative instruments in the biology unit. And physical properties. Okay, so they were actually doing some imaging, and the physical properties team often executed their. They did their testing after the X-ray, the XFRS, and the GCMS, because each of those X-ray fluorescent and the GCMS would give them clues to what they were actually looking at, and then they would make some determinations based on imaging and prior studies by the other instruments. So, okay. So let's see, what's next in here? We've got
A number of our folks represented in there that we've interviewed, actually. And sample site certification. The rock rollin' certification team. I don't know if you can see that, folks, but that's pretty cool. Each one of the sites had to be certified, and so that's what they were doing here. That's pretty exciting. And I hope we're not making you dizzy here as I move the camera around a little bit. And if you're sticking with us still, then we know you're dedicated. Okay, interesting. So technique develop. I'm not going to pretend that I know what that means. I might surmise, but Bonneville is one of the sites. Beta. Interesting. Okay, I'll have to learn more before I can talk about those. Sol 20 is when these happened. Interestingly, the very first sample was taken on Sol 8. So that is when all the excitement began for the surface sampler team. And Dahl was a part of the surface sampler team. And so that's why we have the great fortune of having documentation on all of the instruments from Dahl that were a part of the surface sampler team. So we have interviewed most of these people, actually. And many of them have passed away, actually. But we do this work to honor them. Okay, and the science, actually there's a reference to the science test lander there, which is kind of interesting. So the science test lander was actually at JPL at the time, and you can see those other rooms were also, there you go, we're also at JPL, image processing lab. Obviously, conference rooms, there was a lot of time spent in conference rooms. Okay, more meeting folks. And so this is Viking Lander 2, and this is the site certification schedule. So we've got touchdown, Sol 0, 1539. Yep. 4:39, I guess, in the afternoon. September 30, yep. Some of us were there for touchdown at JPL. I was 11 at the time. Actually, no, I was 10. And I watched it, the landing and the touchdown and the first images. It was very exciting. And then we're moving on to more Sols. So we've got Sol 3, 4, 5, 6, 7, and each of the things that were done on those Sols. So, and meetings. Lots of meetings. Shall we skip to see what some of these are some of the images that were then taken. And my guess is that what you're seeing with these arrows, no, actually I'm not going to guess because I know I'm instantly wrong. I think, actually, I'm going to hazard a guess. And then you guys can do your research too, and we'll all ask questions. My guess is that they're using those within the field of view. They will be able to identify a distance between objects in the field of view. So by creating arrows within and outside of the field of view, they might be able to tell exactly how far things are away on the horizon. So there you go. That's my guess. And if you guys have different theories, go ahead and put those in the comments. That is, I'm not sure what kind of print that is because it's been affected by the plastic, actually, that it was stored in. A Xerox of, it's a close-up, but the paper is obviously a carbon-based paper, which is why it's discolored. Us historians do not like that kind of paper. Archivist historians. Now, here's an example. Okay, we talked about this before. Now, these are not red pen. These are black pen. But you do see here that they have outlined a number of squares. In this particular notebook, they are in black pen. But these are notes on what they wanted to do in these different sites. And then they'll have on the subsequent pages probably the image that you saw before might have represented what some of those are. I'd have to take another look to see, do a little comparison. Okay, there's this. So the thing in the corner you're looking at, that's the surface sampler, the corner of the surface sampler. So that is most likely, yeah, what's in that, the hardware that you can see in that image. And so that's sort of an example of what you can see in the field of view from there.
These are the same field of view from
But from the different camera, yeah. So this is camera
view.
1 and camera 2. But there's no hardware on that one so that you can to be seen. So and I don't see the image from that one in here either. It might be behind this or something. I don't know. Yeah.
The horizon.
Yeah.
The
That.
horizon.
So they were measuring the horizon. Okay, here we go. That's kind of interesting. But yeah, so imaging, a lot of people don't realize that imaging is actually a science as well. And so imaging data is used in the manner that you've just seen us real time to determine things that have a basis for other measurements. So, and then we've got handwritten notes. This was so meticulously done. This was really, really remarkable. So relay time change. This one says it's about 6 hours late, which happens.
It's the relay communications from the lander to the orbiter and back to Earth.
Right. It's actually going to be, but there's a delay, not a delay. There's a delay in time between the sequences, the command sequences that are sent up and down. And they do vary depending upon where the planets are in position. So they were 20 minutes at one point. So when we were looking at the first images, and I think Curiosity called their 7 minutes of terror. That's right, 7 minutes of terror. And I just chuckled and I said, well, Viking had 20 minutes of terror. But yeah, this is really... Now, and you could, in that other image, or the other page, they actually referenced wind and temperature. And so again, you really see the integrated nature of all of the instruments. So it says there winds and temperature. So the data that came from one of the instruments was very, very relevant and useful to the other teams. And that's why having an integrated team as closely connected as the Viking team was really important. That doesn't happen as much on subsequent missions. Okay, let's see. What is this? This is an illustration. Yeah, it's a simple line drawing from an image to identify what they were looking at. Now, this is really interesting. So fine-grained material, clods and fragments. Now, one of the interesting things is that Viking discovered water ice. It was not discovered by any of the later missions. And the way they discovered it was they saw these fine elements on the footpads that initially they thought were dust that was blown there by the winds. And then they realized that the dust would appear and disappear as the temperature would change. And they realized that they were actually witnessing sublimation on Mars. That was a huge discovery that is not talked about frequently enough. So... what have we got in here? More pictures, okay, with more. Let's see here. So these have more of the measurement lines, really, and that it appears that that is really what they are. They're trying to
a stereo pair.
Yeah, to figure out the distances between things. So, study your geometry. Because that's what you're looking at right here. These are the results of some good visual math. And, oh, interesting.
Another small stereo set measurements.
Yeah.
Camera 1, camera 2.
Yep. And these are, well,
Well, those are the coordinates. So those are the written out coordinates of what you would see on the azimuth chart. And then there's little tiny notes, though. This is what's interesting to me. Let's see what those say. Central near point on left hazard. Yeah. I'm not going to try and interpret that, but it is interesting nonetheless. All of this as clues. Here we go. The uplink verification. So this is testing the sequences that are uploaded to the landers and orbiters from Earth, and this is obviously a test on the sequence prior to sending it to the actual craft. And they did this throughout the entire mission. And for both orbiters and both landers, we actually had direct communication with the landers for a period when the orbiters were actually offline. So the latter part of the mission, we communicated directly with the landers. And now this is actually really exciting. This is Mr. DeShazar's work right here. And I'm going to contact his son, who we are in touch with. And that's pretty exciting, because we have yet to see his name on any of the documents. So that's pretty cool. Actually, let's take a picture of that one document. Thank you for your patience, everyone. But one of the things that's really important to us, in addition to the science and engineering lessons, are actually the legacies that these people made with their work and their creativity. Oh, wow, that's a gorgeous picture. That is lovely. That is absolutely gorgeous. Look at that. Now, if we zoom in, you can see that these are from the image processing lab at JPL. They had an amazing image processing lab. And that was was that September 5th? Yes, it had to be September 5th because they were already landed. I had to think about that one for a moment. It couldn't have been 5/9 because we weren't landed yet. So that is September 5th of 1976. Pretty cool. Aha. Well, this is a nice famous picture. So this is Viking 2. And this was the first image that was taken of the surface from the Viking 2 site. Very exciting. And these images actually tell you a lot about the picture itself, and you can actually see the date here. So that was September 4th, 1976. So Viking 2 landed after Viking 1 did. And the immediate response from the scientists was a lot of oohing and awing about the differences, the profound differences in the geology of the rocks that they were seeing. I remember that. It was really interesting to hear about. And these pictures were often taken as kind of an assay of the instrumentation, just to look at the equipment on the lander itself to make sure things weren't broken or dented or off kilter. And so there were a lot of pictures like this that were taken. We have the S-band antenna there, and
with a little Martian dust that landed on it during the landing disturbance.
Yeah, it looks like there's a little something going on there. Could be dust.
I think it's Martian soil. Yeah,
could be.
Kicked up and landed.
Could be. We've got it there as well, though. So what this is? So
this has been flattened. This is created due to the tilt.
Oh, yep, it is. Yep, and that's a really good point there, Tom. Of course, I was just looking at the spot to see if the spot was still there. So this is one of the things I learned from my father. So I began looking and flipping through day by day pictures and looking for the differences in them, because I wanted to find something that nobody else found, or I wanted to find something first. That never happened. But it was pretty exciting just to look. So really good observation there, Tom. Thank you. And noise.
So sometimes the cameras would be deliberately not continuing to scan, but they would just stay focused in one direction over time. So this is time, some tens of seconds, to see if there are brightness variations, like due to cloud changes that make the sky brighter or dimmer. And if the bands are uniform intensity, then there's really no illumination change happening during those tens of seconds.
That is a great description of that. Thank you, Tom. And this is a really good example of why the kind of work that we do is so important, because if you don't see an image, it's data or noise to people that are looking at it, right? So Tom's given us a really good example of why how that happens. But when people are doing intake or a session of things into their museums, and this is commonplace at all museums and archives, they often throw things away that have an immense value because they don't know what they are. And one of the things that makes us unique as an organization is that we actually do not throw away any of our archives because we know they have meaning. And we know that long after I'm gone, there are going to be other people that can determine some of what the relevant data is now because they can compare it to missions data from subsequent years. So we keep everything that's donated to us about Viking, all the Viking things that are donated to us. And these are just some wonderful images. And throughout all those images, you can see how different the rocks are. So we've got a lot more of the same. So let's see. Should we look at one more, or do you think we've
pull out the binders at least?
Let's take a peek at each binder. We won't go into any great detail because we want to make sure that those of you listening don't grow weary, and we can, if we find something new, we will always do another video because we can do that. So what have we got here?
Initial computer load, I think, is what ICL
uplink.
is.
UL is uplink. Okay, so this is actually each of the instruments that would be requesting time for a specific uplink data. So every instrument, so this is kind of fun, every instrument and principal investigator had to actually request time for from Deep Space Network at JPL for an uplink to either send an instruction set or to downlink, get some data sent back. All of those had to be pre-scheduled. And while Viking was happening, there were other missions going on as well. So all of this was very, very, it was a huge negotiation. Let's just put it that way. Really interesting stuff, but they're not the diagrams we're looking for. We will delve into each of these notebooks later in more detail. And that is PSM LS3. I don't know what that is. Well, when we open it up, we might find out, get more clues. But okay, here we've got references to each of the instruments again. So meteorology. Talking about the operating philosophies. Okay. So when things work based on what the maximum rate is. Okay. Storage. Interesting. Okay. Yeah. So this is planning information, which is very, very important. But not what we're looking for today. That's fine. That is okay. We're on a mission, by the way. We have our own mission today. And that is to help Tom get data that he can use. Okay, more planning. Uplink planning. And there's many, many boxes of these notebooks because all of the uplink planning and the data results are in. We have 32 boxes of materials from these. Argon. Okay. Let's see what that is. Acronyms. That's always very useful, actually, when we see keys. Early Atmospheric Analysis Timeline. That's EEAT. Oh, DECSET. So DECSET,
was the
software.
software that was used. And we've heard many comments from many people about the software that was used. And we have actually all of the original deck set software, command sequences, everything from there, because my father worked on them extensively. And there we have a Dr. Klaus Beeman. And Gentry Lee and Jerry Soffen, and I believe it was Henry von Struve, but I may be wrong about von Struve. Okay. Oh, now this is interesting. So this actually is about the argon concentration. The prudent possibilities for scientifically useful atmospheric analysis sequences before the first organic analyses are thus the following. And this is what I mentioned earlier when we talked about the interconnectedness of all of the instrumentation, because the data from one instrument would provide information that would be useful to the other investigations. So this is a great example of that. Oh, this is fantastic. So we won't read all of this to you because you can stop your video and read it at your leisure. But eventually we will be able to digitize all of this material. One of the things that we are doing right now is raising funds in order to to secure a space for our permanent archive where we can actually conduct all of the digitization and teaching students and individuals how to preserve, and actually giving an opportunity to students and scientists to come in and do this with the Viking data. Now we do, as you can see, we do this already, as Tom is here in our archive, and we've had numerous other people, but we're looking for a better site to do this, and raising money to do that. So this is the Rolling Rock site then, yeah. And these are probably images and all sorts of information like that. Looks like images from there, yeah. Images, plans, agendas, meetings. They had the most beautifully documented, this is one of the most beautifully documented missions from what I've heard. Numerous of the investigative, the PIs on other missions that have worked on missions after Viking said that they would have loved to have the other missions. Oh, wait, hang on, what's that? What is this? The Holy Roller, okay, this overlay. Holy Roller vertical profiles. Okay, interesting. Oh, they reference Tektronix. Okay, that's right down the street from us here. Interesting. I'll have to give them a call. Yeah, so you can see a lot of medium that we have to preserve. We've seen vellum, we've seen photographs, we've seen plastic overlays, and yeah. And we preserve all of those things. We're almost down to the bottom now. Oh, here we go. SIP and the Lander Sampling Group meetings. Yeah, okay. That's what that is. Listen to the press conference tape.
Mars orbit insertion.
Yep. Updated. Trim to synchronous orbit scheduled for... Oh, interesting. Okay. Should report the change. No, okay. So a lot of this is what we're doing and then how we're actually reporting it to the outside world. One of the determinations of Jim Martin, who was the mission director, was to make the Viking mission the most open and accessible mission of all times, the most transparent. And as a result, they really did succeed in doing that. Yeah. Pretty remarkable. Uplinks, notes.
take off this weekend if possible. Okay, that's actually a really great note. We know that a lot of people didn't get to take time off because they were running on Mars time, so on sols, and for a period of time, they actually did an experiment and had people go in based on a sol instead of a day, and they determined that did not work well for the mental health of the staff, and so they switched back. But that's how we learn, right? A little flow chart. Does it appear okay? Should we proceed? There you go. And we still use charts like this today, except everything's digital. All right. Well, looks like there's no diagrams in this one that we're looking for, but this is interesting stuff. So thank you, Tom, for your patience too. And we have uplink rescheduling. So as we mentioned before, things do change, and that's okay. One of the things that's really important for any students that are out there to realize is that stress being low is the most important thing. And when things change, it's not a reason to freak out, which I think is it's really hard for young people to come onto a mission and be told things have to happen a certain way, and then be told the very next day that things have to be different. And I just want to say, as a person who's observed these things for many, many years now, it's okay for things to change. So, and it's also okay to ask questions, ask why they're changing. So if you're a student working on things, it's okay to ask why things change and learn from that as well. 7/14/76. So that would have been before landing. Yeah, we've got quite a combination of, there's a meeting that was canceled. Maybe somebody took a day off. No, I'm kidding. That's also interesting. So conflict between meteorology and GCMS. So that would be my father, Jim Tillman, and Klaus Beeman, the GCMS. And those are, that's when scientists have to meet together with the science team lead, which was Jerry Soffen, and negotiate. So these pitch sessions were very important. 7/20. Okay, this is remarkable. Does anybody know why that date is important? 7/20 of 1976, we landed on the surface of Mars. And these are the notes that were taken. The slope is 30 degrees, roughly, approximately, or 3 degrees. Sorry, 3 degrees, approximately, is what the little tilde is. Vertical velocity, approximately 8 feet per second. Leg 1, 271 degrees from the north. I can't read that other number. Can you read that? 1.48
inch penetration of legs, probably. Okay. 3-inch strokes on 2 legs.
On 2 legs. Super healthy lander. Great. Okay, that's kind of awesome. It's a great... Temperature slightly lower than nominal. Cycle 8. SIPs due today at 4 p.m. That is an exciting page in this entire notebook because that's when we landed on the surface of Mars for the first time in human history. And this is the second day. And as you can see, there's a lot going on the second day. Relay links checked, solid uplink cycle, late adaptive to Sol 5. I can't read all of the handwriting. Science summary reports, instrument status reports, very important. Lander, what's number 6? Can you read that? Lander
bus.
Oh, lander bus. That might be, yeah.
3 something volts and
volts.
4 amps, probably.
Yeah. 31.1. It looks like 31.1.
Yep.
Meetings. And then meteorology, seismology, imaging, physical properties, and magnetic properties. Those are all meetings that clearly happened on that day. Wow. That's exciting. So this is real time, guys. Imagine that you're immersed right now in the busy hubbub
of JPL as the science team folks are meeting right after we landed on the surface of Mars. That's what these notes are from. Mission planning. Let's go to this page. What is this? Oops. Biology, okay. Labeled released. The pyrolysis. No GEX processed yet. Temperatures close to nominal. This is 723. So yeah, nothing from the biology instrument would have been processed yet. They might have been testing the instruments, but the first samples were taken on Sol 8. $7:24 the next day. Midnight. Thermal steady state. Okay. The next day, the day after this, the 27th, is going to be really exciting because that's going to be when the biology instruments were first, that sample was first taken. So this would be the planning probably for that. Need time for DA. Sampling site, there you go. M1 this afternoon, downlink. Okay. Instrument status, everything okay. LPAG, that's the lander performance analysis group, yeah. Not getting thermal feedback, that's good. Thermal hot gaze power, less than predicted. Station, what's that bottom one? Station.
Losing data during.
Losing, oh, it's spelled wrong. During direct communication, so it's losing some data. Interesting. Well, that happens. Sometimes there's data that tries to get here and it doesn't. And that's, when you're that far away, I think that's forgivable. It's not optimal, but it's forgivable.
Valve 12.
Yep. Okay, so CO2 against valve 9, open. So this is the sequence commands for the biology instrument in preparation for the samples to be deposited into the instrument. Interesting, okay. And then cycle 8. I'm not sure what that says. Do you know what that says? It looks like delicious, but that's obviously not right. Deletions. Oh, yeah. MSET deletions in progress. Okay. Impact of new acquisition. Okay, I'd have to have more details on that. I can't presume anything here. Oh, deck set. $7:30. So this would have been 2 days after the first selection. Actually, Sol 12. So it would have been 4 days. We're planning for Sol 12. Sol 12. Oh, GCMS temperature problem. Interesting. Don't know what that means. These are on pump spikes. Maybe the last cycle for Lander 1. Yeah, because they only had limited cycles that they could actually do samples on. Cycle 8 over, cycle 9, cycle 10. Now, if people see this and they look at the video where Dr. Patricia Ann Stratt is talking about how they could use the different ampules, the different deposit capsules that the surface, the regolith was deposited into, they could use it more than once, but they had to
the first sample in each one was used a very specific way, and then they figured out some other things that they could do after the fact. So you can look at that video that's also on our YouTube channel. And I'm not going to try and interpret this because I don't. Yeah. We are all learning as we go. Oh, looks like that's the end. Blank paper. All right. Well, that was exciting. That was very cool. Anything you want to say, Tom? Nope.
Fascinating history. As it happened, handwritten notes, the day, real time is amazing.
Yeah. Yeah, it's like being there. It's as close to being there as you can get today. So that's pretty exciting. All right. Well, thanks everybody for listening for this almost an hour. That's pretty amazing. So, and thank you, Tom, for your patience as well. I spend hours doing this and I lose track of time because it's so incredibly exciting. But we appreciate the patience that everybody has with us when we're shooting these videos. So signing off, and go ahead and look at some of our other videos and let us know what you think.